Yep.
This is a really small question, but if you have the comment inside the function, do you want that for formatting, or if it's outside, it's fine?
It should be inside. So we'll see that there are certain conventions that you follow in Python, and one of them is when you're commenting a function, you use this triple quoted string right after the function definition. So it's really the first line of the function. So any, yep. I believe the interface allows you to just upload one file at a time. So make it, yeah, just upload one file at a time. That'll be, slightly easier for the TA, who then doesn't have to click on the folder to open that. And everything that you can do to make the TA's life easier is something that helps you.
Just more of a question about programming. Is there any reason to use the percentages within the strings instead of plus signs?
Is there any reason to use printf formatting instead of plus signs? That depends on how fussy you are about the format of your output. So if you don't like, for instance, that by default the number of decimal places when you convert a float to a string doesn't, maybe it's more than is necessary or something, then the sort of the simplest way to fix that is to use printf formatting than conversion to string. Yeah.
And also, most of this stuff is just questions and answers. So do you want us to display the answers as a return or as a print?
If the question says write a function blah, f of a comma b that takes two arguments a and returns whatever a plus b, then that tells you I would like you to write a function that takes those two arguments and returns a value, doesn't print anything. And if the question says write a function that prompts the user for their name and their weight and their height, and then prints a summary of their BMI information or whatever, then that's really something that should be reading inputs from the user and then printing results. So I think the testing is the best place to look for how that should work. So look at the test code. Okay, good. So I noticed there's a lot of activity on the forums. That's great, and I noticed there's a lot of disparity, which is not surprising at this stage. So some of you have been programming for quite a while. Some of you have even programmed in Python before, and for some of you, this is really your first experience doing any real kind of programming. And it's good that you help each other out. So for those of you getting the help, it's good, and for those of you helping, I find at least that helping someone else with something gets me to organize my thoughts about that in a careful way, and actually helps me understand it better as well. So the best way for me to learn things is actually to teach them to someone, or if there's no one to teach them to think about how I would teach them to someone. So it's good for both of you. And on the same vein, for this coming week and maybe even the following week, so the tutorials for some of you are really easy. Some people even do them before they get there, and for others they're more work. So again, if the tutorials are easy for you, go there and help someone else out. So get them done. Do what you need to do, and then help out one of your neighbors. It's good to make friends, because it won't always be this easy, and eventually, it's nice to have some people to talk to about the coursework. Those of you in the learning community, maybe you know this already, or you recognize this if you signed up for that. But all of you are part of this same first-year community here, so help each other out. All right, so today we're going to get into some slightly more advanced stuff, and if you've programmed before in other languages, then you may think you know all about this, but you'll see that probably in Python things are quite a bit different than what you're used to, and you can do things in much simpler ways in Python. And what we're going to talk about today is arrays. So let's fire up our interpreter, and let's define an array. So in Python, I don't know, well, I do know why they did this, but I have difficulty living with it. So there are these things that the Python community calls lists, and I will constantly refer to them as arrays. So when I say array and some Python documentation says list, we're talking about the same thing. And when I say list, I really mean the same thing. So for us, array and list is the same construct. So let's define an array. Let's call it A. And I'll say that that array contains some stuff. It contains a 1, a 6. It contains my first name, my last name, and a 42 for good measure. So there's A. It's what I'll call an array, or in Python we'll call a list. So arrays or lists are a lot like strings. So we said a string is a sequence of characters. So sequence has this important connotation that the elements occur in some specific order and they're indexed in a certain way, while arrays and lists are just like that. It's a sequence of things. They don't have to be characters anymore. They can be anything. But they occur in a specific order. So this is the list that contains a 1, followed by a 6, followed by the string Pat, the string followed by the string Morin, and then finally the string 42. So what are these good for? Well, arrays are probably the fundamental the fundamental data structure in all of computing. In fact, if you just think about what a computer is, well, there's a processor and there's a memory. And what's a memory? Well, a memory is essentially just a big array of bytes. So there's an ordered sequence of these bytes that can be accessed, and it's really just a giant array of bytes, and now the number of these bytes in a computer memory is measured in the billions, and so that's really the fundamental thing. Underlying everything inside a computer are arrays. And the nice thing about arrays is well, you can put lots of stuff in them. They can be big, they can hold lots of data, and computers tend to be really, really fast at processing them. So we can add up the numbers in an array or do some calculation on some numbers in an array much, much faster than any human could do, even with the cheapest computers. Okay, so you've seen how to define an array, one way to define an array, which is just enclosing its elements in square braces and separating them by commas. So you want to see another example. B is equal to 1, 2, 3. There's another array that contains those 3 integers. Those of you coming from something like a Java background or a C background may be a little surprised that in the same array you can put integers and strings. There's no problem there. Put whatever you want in an array, mix and match whatever types you want. So these arrays are sequences. The elements are indexed, and the indices start at 0. So this first element in an array is at position 0. This is at position 1, position 2, position 3, and position 4. So in general, it's 0 up to the number of elements minus 1. There's 5 elements here, so it's 0 through 4. And you can access them by index. So if I ask for the element at position 0, what's that? 1. If I ask for the element at position 1, that's 6. And if I ask for the element at position 2, that's Pat. So you can get the elements out of an array by indexing this way. And of course, you don't have to specify the index exactly as I've done here as a literal. You can just, if you have an integer like this, you can say, what's a at I? Well, that's a at 4, which is 42. So not only can you get the elements out of an array, but you can also set them. So say I change my mind, a at 3 should be 24. Let's look at a again. This element that was at position 3, this string, has now been changed. Okay. So these expressions, a at some position, they basically refer to that element in the array, and you can use them on the left-hand side of an assignment, or you can use them inside of any expression. So for example, a at 3 plus a at 4, 66. That's just 24 plus 42. So put them inside any arithmetic expression. There you go. And if you think about it a little bit, well, you'll realize now that, well, you may not realize it, but it's good to keep in mind that really what we're looking at here is another example of an operator. So this square braces is what's called the indexing operator, and it has its own level of precedence in the hierarchy of things, of the bed mass plus what we've seen now is comparisons, and now we're seeing indices. Usually it behaves exactly what you want, exactly how you want. It basically refers to the thing just to the left of it. So if I say 2 plus a at 0, 1, 2, 3, 4, then I get 44. This, on the other hand, causes a problem. So it works pretty much as you expect it, and so usually that's why you can put the spacing however you like, but the convention is really this indexing operator should be glued to the thing that it's dereferencing. So this continues to work, but it gets confusing, right? 2 plus a at 4. It's certainly easier to read this and understand what's happening. Okay, so you can index, great, and you can assign values at indices in an array. That's no surprise for those of you who have worked in just about any other language with arrays. You can also do fancier things. So let's go take a peek at A again. Let's ask for A at 2 with a colon afterwards. Anybody know what that's going to give me? Yeah, everything after position 2. What's that? It includes the element at position 2. 0, 1, 2. So it starts with Pat and then has the rest of the array. And this is actually just one way of using the more general thing is that you specify the beginning index and the finishing index that you would like to see. So it's usually the typical thing to do would be to specify 2 integers here, the start and the end. So for example, if I ask for 1 up to 3, I get 1, the element at position 1, the element at position 2, but I don't get the element at position 3. So it includes this left start point, but does not include this right index. Similarly, 1 up to 4, that will leave out the 42, which is the array element at position 4. Okay. So that's called a slice. It gives you back another array which contains the elements that you're asking for in this slice. Yeah. So if you want the first three elements including 0, so one way to do that is to say 0 up to 3. Another way to do that is to say everything up to 3, not specifying the first element. So if you leave out the start index, it assumes you mean start at position 0. And if you leave out the end index, it assumes that it should be the final part of the array. Okay, its position, the size of the array, basically. So if I want the whole array, so A has length 5. If I want the whole thing, that's basically 0 up to 5. Or another way of saying it is don't specify either the start or the end. Although, of course, that's just A, but that's fine. Yep. Yeah. So 0 to 3. So you never include the final index. So the right index, the larger one, is not included in this thing. So that's why, right, I can ask for the slice 0 to 5, but I cannot actually ask for the array at position 5, because there is nothing at position 5. So the slice 0 to 5 gives me 0, 1, 2, 3, 4, and leaves out the 5. Yeah.
What happens if we make a -1, or in brackets a -1 equals no number?
Like this?
Yeah. Oh, okay, so it goes in backwards order from right to left.
Yeah. So there's a surprise in Python. If you use negative numbers, you're actually starting at the end. So -1 is the final element in the array, and -2 gives you the second last element. So -1, -1 there, -2 there. So so it's sort of like, it's not exactly true. Well, I won't confuse matters, because it's not really true. So if you use negative numbers, well, that's just indices starting from the end of the array, but with -1 being the last element, -2, and so on. So is that consistent? Does that make sense to you?
I would start with -0.
Yeah, -0 should be the last element, right? If 0 is the first element, except that -0 and 0 are the same thing. So so you have to do something different, right? Because -0 is 0, right? And so
Just do that. Just take the array length.
yeah. So basically, when you say a at -2, this is really a at the length of a -2, if I got that right. Yeah. And that would be more readable to someone who comes from another language, but in Python, it's no problem. Something else you can do, and I'm going to redefine a here, just to be a bunch of strings. That's probably enough. So there's a, which is a bunch of strings. You can actually say, let's say I go from 2 to 8 in this array. That's C, D, E, F, G, H. But I can add a third parameter here and say I want to get the elements from 2 to 8, not including 8, and I want to count by 2s. So I want to skip I want to skip every second element here. So start at C, then add, so start at index 2, then add 2, get the next thing, which is over here, the E, and then add 2 to that index, so we get index 6 at this point. That gives me the G, and then the next one takes us past the end of our range. So with these slices, you can get really fancy stuff. So you can grab subarrays, you can grab everything from the beginning up until some point, everything from the end up until some point, and you can even do things like take every second one or every third one. And again, you can leave out some of the arguments. So here, give me every second element of the array starting at position 0. So that would be all the even indexed elements. And here are all the odd indexed elements. Great. And here's one that shows up sometimes. Weird if you've never seen it before. But if you have to guess at this point, what do you think it does? Yeah, counts backwards. So give me the elements counting backwards to starting from the end, basically from 0 or -1, I guess. And so this is a shorthanded way of reversing an array. Okay. So here comes a surprise for you, maybe. And that is that strings are just arrays. So they're just arrays of characters. Each one is a sequence of characters. So you can, all of the things you can do to arrays, you can do to strings. So string at position 0. So let's look at S. There's S. What's at position 0 in that string? T. What's at position -1? G. Okay, so we can get every second element, whatever you want. Yeah. So so strings and arrays, they're at least the indexing operations that you can do to arrays, you can also do to strings. One thing you don't do really is this. You don't say S at 5 equals something. So you can't assign values to the elements of a string. So in Python, strings are what are called immutable. That means when you make a string, you can't change it. So you can derive other strings from it, but once you make a string, that's it. It's there. It's not going to change after that. And that we'll see a little bit later. That's a good property to have for things like strings. And sometimes you want to turn a string into an array. And this happens, for example, well, there's lots of times it happens, and we'll do an example. But perhaps something you might imagine is you have some formatted file where each line in the file is maybe it's a spreadsheet. So a CSV spreadsheet, and you might have strings in it like this, which are, name, first name, last name, student number, I don't know, gender, whatever. If this was in a spreadsheet, there wouldn't be spaces at the heads of these things. So like that. So there's a string, and let's assign that to a variable. And you can take a string and split it. So here this says, take this string S and split it using this thing as the place to denote the places you should split it. So everywhere there's a comma, split S into a different string. And what you get back from that is an array of strings. So everywhere there's a comma, So this just basically scans S until it hits a comma. Everything it's seen up until that point becomes the first string. Then it keeps scanning until it hits another comma. The next piece becomes the next string, and so on. So this splitting a string is a really handy mechanism to have, and we'll play around with that a little bit later in the class. But just know now that you can do this. And I already showed you this, but you can ask for the length of a string, and you can ask for the length of an array. So a lot of things in common between strings and arrays. Here's a really useful function that's built into Python. It's called the range function. And it takes an integer argument, and what it gives you back is an array. And it gives you back basically the indices. So that array contains the indices of an array whose length is equal to the argument. So this gives me back an array of length 10. So it has 10 elements. And what does it contain? Well, it contains basically the indices of those elements. So range of 10 gives me the integers 0 through 9 in an array. Range of 100 and range of 1,000 does it exactly what you think. Now you can also give it 2 arguments, in which case it will count from the first argument up till 1 minus the second argument. So range 10 to 20 starts at 10 and goes up to 19. So this is a little bit like, the array slices. So you can think of the first form as being just specifying the last element. The second form, where you specify 2 arguments, you're specifying a range. So then you may guess that there's also a third form where you can specify an increment. So this says, give me a range that contains 10 up to 20, counting by 2s. And at least things are consistent. When you specify a range like this, it doesn't include the right endpoint, the larger value in the range. So 10 to 20 really gives me 10 to 19. Yeah. Okay. So any questions about that? Easy? Clear? Yeah.
What kind of size limit would you get on
As much memory as is available to your Python interpreter. I don't know. So let's should get rid of that. So I don't know. I don't think it should be a problem to have 1,000,000 elements. There. So there's an array with 1,000,000 elements. If we print it, it's going to take a while. We can try. Should we try? Should we look at it? No? A trillion? Yeah. A trillion will be a problem. Well, because a billion is a gigabyte at least, right? So a trillion is 1,000 gigabytes. So you can make really big arrays really easily this way. That's certainly easier than typing them in by hand. But you might wonder why this special range function for making these special kinds of arrays. Why do you want arrays that contain these sequences of integers? Well, it turns out that the way you do a lot of counting in Python is just by specifying an array that contains the things you want to count. So here, for example, if you've done other languages, you may have used for loops. So you've used for loops before. And what do you do with for loops typically? Yeah, so what is it like a typical for loop looks like? Here's one that I have probably written thousands of times in a language like C. It would be For I equals 0, I is less than n, I plus plus. It's really the standard thing. So what does this do? This counts from 0 up to n minus 1. And that's exactly what range does, right? If I ask for a range, say n is equal to 20, range n, I get the element 0 up to n minus 1. So the way you do for loops in Python is you say for I in range, let's say n, put a colon, and now you put the inside, whatever you want to happen inside this for loop. Let's do something simple, print I, and we're done. Okay. So let's yeah, it's what you call a for each loop in I don't know what language. Well, in Java you call it for each, but the keyword is still just for. So so let's write that down. So we'll make a function called count to n. Print the integers 0 through n. And that's for I in range n, print I. Okay. So basically this sort of for loop says, it takes two, well the for loop says for some variable, in this case it's called I, in some array, in this case it's the array that we get from the range function, which has 0 up to n minus 1 in it, do whatever the following block of code tells you to do. And of course you can put as much as you want in that following block of code. And now, keeping in mind that, as all of you are learning, the way you specify what's in a block of code in Python is just through indentation. So, you know, I can put as many instructions as I want in here. And that all ends up getting done. So let's test that. So there, that counts to 10 in increments of 0.25. Or rather, it counts from 0 up to, but not including n in increments of 0.25. Okay. Is that clear? Is it clear that this is a really useful thing to have? Yeah. Okay, good. And I really want to be specific here, and you know, there's nothing special about range. So, for example, we had a long time ago, it's gone now, but I think we can get it back. We had an array called, there it is. We had an array called A, now it's called AA, that contained these things. And I can do the same thing for that array. It doesn't have to be an array of integers, so I can say for x in the array AA, print x. And that prints iterates through AA and prints each of the elements. Okay. So for some variable in some array, execute the following block of code. So assign that variable the elements of the array one by one. Each time you do it, execute the block of code. Okay. Questions? So Python has for loops, like sort of like you're used to, and you know, for those ones that that count, you know, the for loops that count from 0 through n, they're, you know, as simple as possible. They're just for I in range n. But of course, with this range function, because it supports all of these other strange ways of counting, with increments and between, you know, A to B, you can do lots of things. So for example, what if I want to really count from 1 up to 10, including 1 and including 10? So what is the range for that? So that's just 1 to 11. So I can do that. So that's great. What if I wanted to maybe count from 10 down to 1? Like this? We got the empty set there. So for range, you want to do something, I think it's like this. We'd play with it to find out. So that'll take you from 10 down to 2. So we'd want to go to 0. Okay. So it starts at the first argument and counts 2, but not right up to the second argument, and the third argument specifies the increment. If I what? So it starts at 10 and says keep counting till you're bigger than or equal to 0, and so there's nothing to do. And if you want only the even numbers, there you go. So you see, most of the things you do with these fancy for loops, you can get with range fairly easily. And let's just suppose I want to do something that takes a array as an argument and prints it in a nice way. So I could do something like print some really fancy curly braces. And now say, go through the elements of A, and I don't know, print them somehow, maybe print X. And here's something that I've not shown you before. If I put a comma at the end of a print statement, anybody know what that does? Yeah. Where was my... So if I put a comma at the end of a print statement, it keeps it on the same line. In fact, what you're doing there, it's maybe a bit difficult to understand what's happening there. It's nothing magical. It's actually asking print to print a tuple whose last element is empty. So a tuple is a bit like an array. We saw that you can return tuples. You know, we returned pairs of things from some functions. You're doing it in your assignment. So a tuple is a bit like an array, and this tells print, I want you to print this tuple that has this string, and then its second element is nothing, and that's somehow a clue to print that when it sees this, it just knows it shouldn't put a new line at the end of whatever it's printing. So just put a comma after whatever it is you're printing, and it'll not put a new line there. So now we'll pretty print A. So I don't know, pretty or not, there it is. Okay, so far so good, so easy. What other things can you do with arrays? So we have an array A, we have an array B. What do you think A plus B is? So extrapolate from what you know. Yeah. A followed by B. So the elements of A followed by B all in one array. So that's the generalized version of adding two strings together, right? When you add two strings, you get the sequence of characters in the first string followed by the sequence of characters in the second string. And just like when you add two strings together, it doesn't affect A, it doesn't affect B. It's really giving you a new array that is that contains all the elements of A and all the elements of B. So that's good. What about something like this? Yep. So let's think about it. You know, mathematically, B times 3, that's like B plus B plus B 3 times, right? So that's B plus B plus B, and so B times 3 is the same thing. So, so it interprets multiplication of an array times an integer as being like adding that array to itself that many times. So it's a fairly natural interpretation of that.
What would you code if you wanted to actually multiply each individual spot by, like, say, 3? Would you actually have to, like, individually go through the for loop or something? Or?
Well, so here's a question. How would you let's say if you wanted to multiply every element of the array times 3. So let me just show you one thing, and then we'll see how you can do that. So here's A, and I can do, there's a method for arrays called append, and it takes an array as an argument. Okay. And it doesn't take an array as an argument. It takes just an item as an argument, takes something as an argument, and adds it to the end of the array. So here A is this A up to J, and if I say A.append K, then suddenly now K is added to the end of this thing. So that's not the same thing, and I really need you to pay attention to this. Is that the same thing? Well, I just told you it's not, as doing something like this. Well, let's go to L now. So if I say A plus L now, what do I get? Yeah. So I get the L added to the end. Yeah. Okay. So adding A plus L gives me a whole new array that has all the elements of A plus, well, the elements in this second array, which is just a single element. Gives me a whole new array like that. On the other hand, if I say A append L, then really what I've done is I've changed A. So A is really different now. It's not a whole new array. It's the same array with an extra thing added to the end. Yeah.
Should we be able to do like A plus equals the new element as its own array? So A plus equals the next letter in the alphabet?
Well, so if it works, it would have to be given an array argument. So let's try that. Yeah. So plus equals an array is the equivalent of appending that whole array to the end. Okay. So now the question was, what if you wanted to take an array and multiply all its elements by 3? Okay, so we have an array A. We're going to assume it contains numbers. Let's say return a new array where each element of A is multiplied by 3. Okay, do we know enough to do that now? Yeah, how do we do it? Yeah. Anybody? Yeah. Okay, so that, all right, we can do it that way. For I in what? In A? Is that going to work? Yeah. So A is this array that contains a bunch of integers, right? So maybe A is equal to range 5 to 15. So there's A. And now if I say for I in A at I plus equals 3, or equals A at I times 3, so what's going to happen here? So during the first iteration of this loop, what will happen? No. Not exactly, yeah. Where, what? It should be... Yeah, that would be the same thing, but what's going to happen here? Let's think this through, yeah.
Take that value and just put it out 3 times in a row?
No. Let's try it. Let's try it and see. So there's a lot of confusion. Okay, so we get an error. Let's take a look at A. Anybody see what happened there? Yeah. Yeah. So when we said for I in A, I now takes on the values of the elements in A, one by one. What's the first element in A? It's 5. So then we say, okay, A at 5 equals A at 5 times 3. So what's A at 5? 0, 1, 2, 3, 4, 5. So that's number 10 here. And indeed, that happened. We took that 10 and we multiplied it by 3 and we reset it to that. And then, well, the next thing was I took on the value 6, which changed this one to 33. Then I took on the value 7, which made 12 to 36. Then I took on the value 8, and then 9. And then finally I took on the value 10, and there's no element in this array at index 10. That's where we got the index out of range error. So let's just check that. So if we ask for the 10th element of that array, there's only 10 elements. That one is not there. Okay. So how should we have done that? Yeah.
You could either create a new array and take everything in the array, multiply by 3, or you could go...
Well, but how? The problem wasn't really any of that. I mean, it depends what we want to do, whether we want a new array or whether we want to change the original one. But the problem was that we were counting wrong, right?
Yeah, you could just do a for loop and do range, like A.
Yeah. So really, we don't want I to take on the values in A. We want I to take on the indices in A. And for that, right, the length of A is 10 in this case. And so we want I to take on the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so, so that's what we do. And then we can, however we want, we can say A at I times equals 3. And then it works. So now we've multiplied each element in A by 3. 5 becomes 15, 6 becomes 18, 7 becomes 21, and so on. That's great. What if we had wanted, for example, not to change A, but to return a whole new array? Yeah. Any idea how we would do that? Yeah.
We put like B of I would equal A of I times 3.
Yeah. So if we do it this way, we'd want a whole new array, let's say called B. Maybe we'd start with it empty. I don't know. That's one way to do it. And then say B dot append A at I times 3, and of course we want to do this. We don't want to make that counting mistake we made before. So this says create an empty array B, and now iterate over the elements of A, the indices in A, and for each one of those append its value to B times 3, and then finally you have to return B. So there, that doesn't change A, that just gives you a whole new array. Now it's a little bit long-winded, right? I mean, that's a little bit longer than maybe we would have liked. And Python, this kind of thing where you take one array and you derive it from, you make another array out of it in some way, it's a really common operation. And it turns out that there's a third way of well, there's many ways of creating arrays, but there's one that's really handy for those kinds of operations. And it's what's called a comprehension, list comprehension in Python, but remember for us, list and array means the same thing. And basically you can specify an array in Python by saying what it is that you would like in the array, so what the elements look like. So for example, I would like an array that looks like 3 times x. For what values of x? Well, I would like that for the values of x that are in the array A. So that says I want elements that look like this, 3 times x, and I want that for every x that's in the array A. So that's a lot shorter than this function we just wrote here, right? I mean, that's does exactly the same thing and does it in one very easy to read line. Anyone just studied discrete math at all before? Anyone seen this before? No. So this looks a lot like, if you haven't seen it, don't worry, but you will see when you take a discrete math course, this is a sort of standard notation for defining sets of things. You specify what each element in the set looks like with some parameters, and then you do that. You specify which range of parameters. So what are the parameters? Well, these should look like 3 times x, and I want that for every x contained in A. Really useful way to do things. Okay. So how would I, for example, get an array that, let's say, takes A, is the same as A, except it has 2 added to every element in it. Yep.
We could try, I'm not really sure, 2 plus x for x and for x and
Yep. So that works. So you just specify what it is that you want it to look like, and then specify what's in there. So how about if we wanted to square every element? X squared for x in A gives us all the squares. Yeah. So it's pretty efficient, right? So, and sometimes you just want this for a range. So I don't know, I could just do this for range 20. This will do this for 0 up to 19. X squared for 0 up to 19. What's that? How do you mean? No, so this range function, yeah, I mean this range function creates the range 0 through 19, but then this whole comprehension makes that into an array that contains 0 squared, 1 squared, 2 squared, and so on. But you can, that's just creating an array, so you can assign that to whatever you want. You know, my array equals. So it's just, it's just another way of defining an array, and yeah, usually you save that into a variable because you probably want to use it again. Easy, clear. I mean, it's very natural. I mean, you can almost read it, right? Read this as an array. This open square brace. So an array has x squared for x in this range. And range means 0. Range 20 means 0 to 19. So once you get used to, that's way better than this, right? I mean, that replaces this code here. And it's way simpler. So this code is it's 4 lines of code, maybe 3 if you don't count the return statement, but. I don't know. I find it much clearer what's happening here than what's happening here. Okay, so here's some other things you can do with arrays. So what we just saw is what's called a comprehension. Comprehensions sort of replace another thing called a map. So a map is well, let's do an example. So we'll define a function called add2, takes an argument x, and returns 2 plus x. And let's say I have this array A. So I can say map A with add2. Wrong way around. Map add2 onto A, and that does essentially the same thing as this comprehension did. So it says give me a new array where for each element, the way I get an element is I take an element from A and I apply this function called add2 to that element, and that becomes the corresponding element in the new array. So we could have also written that equivalently as add 2x for x in A. Same thing, right? What's that? No, it's just taking each element in A, calling add2 on that value, and storing that in this new array that it's making for us. Yeah.
So the map you use, does it change the contents of the
No, A is still the same. So it's just deriving a new element from A. So map comes from some math terminology. It's like you'd have this function add 2, and you want to know for each element in A what does this function map it to, and so it creates that. And so now, for example, add 2 is super simple. You would never do this, but if this was a really complicated function that took a while to compute, now you would have a whole bunch of pre-computed things, and you could know these values, right? So I would know, for example, that add 2 of A at I, well, that's equal to, well, I didn't assign it. Add 2 of A at 1, well, I know that that's equal to B at 1 from now on. Right? That'll be true for any 1, 2, 3, and so on. But that's not really so important. So map is one of these things. One that is but I suggest not using map because you can instead use these comprehensions of this form instead. But there's a similar thing to map, and it's called reduce. So what you do with reduce is you define a function. Oh, we've already got it. We already wrote that function. So we have a function called added up that takes 2 arguments. And so we have A, 0, 1 through 3, 4, 5. And we can say reduce, added up. Let me just, A. And that gives me 15. So added up is a function that takes 2 arguments and returns their sum. And when I call added up on this, somehow, so what happened there? It added all the numbers together. More specifically, what it did was it added 0 and 1, and the answer was 1. And whatever that answer was, which was 1, it added 2 to that, so it got 3, and then it added 3 to that and got 6, and then it added 4 to that and got 10, and then it added 5 to that and got 15. So it basically starts with the first 2 elements, applies this function to them, and that reduces it to those 2 elements into 1, and it takes that thing and the next element applies this function, which takes 2 arguments and returns 1. And so on until it summarizes, reduces the whole array into a single thing. So for example, I could do, instead of added up, I could say multiply it AB and return A times B. So anybody tell me very quickly what the answer is here? 0, because the first element of A is 0, so it takes A times 0 times 1 is 0, and then 0 times 2 is 0, 0 times 3 is 0, 0 times 4 is 0, and so on. But if that range were, let's say, equals range 1 through 6, do that again, then we get 1 times 2 times 3 times 4 times 5 very quickly. Okay. So this reduce thing is useful for taking a whole array and turning it into one item. What if we had, for example, an array of strings that we wanted to concatenate them? So we wanted one string that was just a concatenation of everything in the array. Could we use a reduce for that? What's that? Yeah, well, let's see. So we have this function added up that adds 2 things together, and actually we don't know what those two things are. They could be numbers, they could be strings. So let's see what happens. Let's change A now so that it's an array of strings. And we will reduce A by adding it up. And indeed, we get the concatenation of all these strings. So this takes the string A plus the string B, gives me the string AB, and then it adds that to the string C, or adds the string C to that, gives ABC, adds the string D to that, gives ABCD, and so on. Yep.
Would that work if you had an array of both integers and strings or characters?
Well, let's find out. So let's put a 5 there. Nope. So it works right up until the point where it tries to add the string ABC to the integer 5 and then says, I don't do that. Addition doesn't add those things together. If you really wanted that to work nicely, then the way to do it would be to say something like this. So the way you add two things is to say convert A to a string, convert B to a string, and add those together. Anybody see why that didn't work? Yeah, good. Because I wrote a function that added two strings together but didn't return anything. So it reduces, the way it reduces two things is it reduces them to nothing. So now it will return those things. And so there. So if you really want to take an array of anything and treat all of it as strings, this is a way to do it. And now I'm going to show you something a little bit strange. So it's kind of annoying to have to keep defining these functions like add to and add it up and all this stuff. So there's just almost, well, there's a few places you use it, but the first and most common are for things like map and reduce. There's a way of defining functions without even bothering to give them a name. And that looks like this. See if I got that right. So just to So this, remember, reduce takes two arguments. The first one is a function, and the second one is an array. And here's a way of defining a function that takes two arguments, x and y, and returns the value x plus y, but doesn't bother ever even giving a name to that function, because you don't actually care if it has a name. You just want to, the only thing you want it for is to pass it into to reduce. So this is called a lambda form. And it's, it is what it looks like. You write the word lambda, you put a list of the arguments separated by commas, and then a colon, and then whatever this should evaluate to. So here this complains because, remember, A still has this integer in it, and it gets angry when it tries to add the string ABC to the integer 5. So you can convert x to a string and convert y to a string. And you get the same result. And that's just a shorthand, because when you're doing things like reducing and mapping, very often it's a really simple operation you want to do, and it's really kind of annoying to have to write a whole function just to do something like add two numbers together. So, so you just sneak that in there. It also makes it perhaps a little bit easier to read, because then the person who reads this line of code doesn't have to go and look up somewhere else where that third function is added up and what it does, they can see right here that the function you're doing adds these two things together. Okay, good there. And finally, so we're back to this array A with this this range, and we said we saw, for example, you can do things like 2 times x for x in A. That'll give me 40, 42, 44, and so on, like this. If you just want a copy of the array, you can just say x for x in A. It gives you exactly the same thing again. And in this this funny comprehension notation, you can actually add a condition. So you can say x for x in A if something is true. So for example, so this says give me x for x in A if x mod 2 is equal to 0. So what does it mean for x mod 2 equal to 0? Yeah, so that means x is even. That means if I divide x by 2, there's no remainder. And that gives me only the even numbers in the array. Okay. And of course you can combine these things, so you can say 2 times x for x in A, but only if x mod 2 is equal to 0. That gives me the same elements, but now they've been multiplied by 2. So there's a lot of power here. You can both map the elements and select only a subset of them that meet a specific criteria. So in this case, it's only the even ones, or I could ask for only the odd ones. So you can get a lot out of this way. So I just want to show you a couple of cute examples, maybe. So equals. Okay, so on my system there's a file. It's called user share dict words, and maybe not surprisingly, it's a dictionary of English words. So there's 99,000 words in that dictionary, and so all I did here was I opened that file, I read the whole thing into a big string, and then I split that string. And split with no arguments basically splits at new lines. And that file is formatted in such a way that each word is actually on its own line. So we could, if we want to take a peek at what's in that array, we don't want to print the whole thing, but we know how to do slicing now, so we could look at, I don't know, the words 100 to 110. So there's those words there, and 1100 to, so we're still in the A's at that point. So there's 99,000 of them, so I don't know. So you see there's lots of words in there. Great. So do you guys know what palindromes are? Yeah, so what's a palindrome? It's the same, it's a word that's the same whether you write it forward or backward. So here I have a list, a pretty good list of the words in the English language. Can you tell me how I might find all the palindromes? Yeah. Yeah. So a list of all the palindromes I'll get by saying, look for the words W for W in words. So far that's just going to give me a copy of everything there. But only if W is the same as, we saw this already, the reverse of W. Okay, is that clear? Let's see if it works. There you go. And palindromes tend to be funny sometimes, so you get poop and redder, solos, stats, pop, boob, that's another one, madam, ma'am. So there's not that many, right? And 99,000 words. It's not a complete dictionary, but it's pretty good. Okay. So those are the palindromes, and I mean that's pretty impressive, right? In 2 lines of code, we got a list of all the palindromes at least in this dictionary. One line was to open it, and the other line was to extract the palindromes. There's something else called an anonym. Anybody know what an anonym is? Yeah.
Is it the words that have the same letter?
No, those are anagrams. Yeah. Yeah.
I think it's the word that makes the opposite of another word.
Now that's an antonym. But there are like antonyms. They come in pairs, and it's basically an antonym or an anonym is a word that if you reverse it, you get another word. So we'll look. So basically, it means that I have some word, I write its letters backwards, and that's another word. It's not just some garbage sequence of letters. It's actually another word in the dictionary. So, anybody know how we could get those? Yep.
Would it be the same, sort of the same thing, but you would make the first, like W forward equals W backward?
Well, it's a little bit more complicated than that, because here all we were checking is if W forward equals W backward. But now we want to know, is W backward anywhere in that list of words? Of all the words we know. Yeah. Go ahead.
You have to make a second loop that would check the backwards word against all the other words.
Yeah.
And that's
Okay. So it turns out that arrays let you support a lot of things, and one of them is asking if something is in the array. Now it's not terribly efficient, but you can do it, and it looks like this. So for example, I can ask, is orange in words? The answer is true. I can ask, is orangina in words? The answer is false. So in that list of words, orange occurs, but orangina does not. So does that suggest a way of checking for antonyms? How do we do it? Yeah. Neither of you. Yeah.
you just, if you reverse the condition, then it will be W in brackets.
Yeah.
Equal to, W in bracket in words.
Yeah. So we look at a word, and we ask if its reverse is also in the list of words. And it takes a little while. So why does this take so much longer?
Every time it searches, it goes through here.
Yeah. So now we have 99,000 words, and each one we do, we look in the list of 99,000 words to see if it's in there. You can make a rough guess about how many calculations we're doing here. So that's, well, you know, 99,000 times 99,000. So that's a million. It's a little longer than we want. So I'll take a shortcut. That I'll explain to you later, and see that we can do this much more quickly. And so here's the list of anonyms. So notice every palindrome is an anonym, because if you reverse it, you get the word itself, but you get a lot of other ones there. Evil is the same as live, gum and mug, knits as stink. Lots of ones that you just wouldn't think of. Spoons as snoops. Sward as draws. And of course the list is maybe almost twice as long as it needs to be, because each one is appearing twice in here. So we have rot, and of course we'll also find in there tor. There it is. Okay, so that's it for today.
You also said a limit though of like, I don't